Good morning. We know that there are two kinds of statistical learnings. One is called supervised and another one is called unsupervised. In supervised learning, we give historical data to the model. Historical data means we have captured the observations over a period of time. The period may be years or months or days, whatever it may. We have observed the data over the period of time. These are called historical data. We are giving this kind of historical data to the model, supervised model. So here we are not only giving the data, we also specify this is the target variable for which we needed to predict the value in future. So when we give the data set, we identify this is the target variable and the remaining variables are input variables, and the model needs to determine the relationship of target variables with each and every input variables so that in future it can predict when it is given a new data set. Because we are cautiously making the model learning from our historical data with additional piece of information, we say these models are supervised models. Another one kind of models is called unsupervised models, in which also we give data, but we only give data. There is no additional piece of information we are giving. Only the data will be given. The model, one of the models in unsupervised is called clusters. In clusters, we give the data, no additional piece of information. The cluster model responses is giving us a number of subgroup of data. This subgroup of data is called a cluster. So, for example, we have got a customer information about from a marketing department. The customer information may contain their democratic characteristics, lifestyle characteristics, their buying capability, their living standard, all those things we have got as characteristics from the marketing team about customer data. Now we give this data to the cluster model, one of the unsupervised model. We only give the data. There is no additional piece of information we are giving. So what the cluster model will do is it gives a subgroup of data, a different clusters. Other than that, any additional detail is given by the model. It is our responsibility to analyze each and every cluster to assign any meaningful label to those clusters for our future reference. For example, in a cluster, we have found the characteristics as the age group is 30 to 40 years, the annual income of the people is 5 lakhs to 7 lakhs, and they are from suburban area, then we can give a label to that particular cluster as suburban middle class mid-age group. Likewise, we can also analyze the characteristics of other clusters and assign a meaningful label for our further reference. Then this kind of segmented data can be given to the marketing team. Then they can come up with some kind of strategy to their marketing advertisement. So in supervised model, we are not only giving the data, we also specify some piece of information about the data so that the model can learn, and then the model can be the data can be split into training and the testing. Training data can be used to learning the data, and the testing data can be used to evaluate the model, that is to evaluate the performance of model. Once everything is satisfactory, then we can use the new data to find out the uh, to predict the value of target variable. So because it is cautiously we are training the method, but on the other hand, the unsupervised we are not any training, we are not giving any training, only the data will be given. And in the supervised training, we can also split this into two the two learners. One is a classifications models and another one is the regression models. We know very well that and the variables can be splitted into two kinds, two types. One is categorical and another one is numerical. In categorical, the categorical data will group the data into different groups. For example, it may be the gender. Based on the gender categorical variable, the group can be split into male group, female group. Based on the region categorical variable, the group can be split into north region, south region, east region, west region likewise. So the categorical variables are used to group the data. On the other hand, the continuous variable, nothing but numerical variable, those are having values in any number. It may be 1 to infinity, any number it can have there as a value. So these are all called continuous variables. The models which are used to predict the target variable whose values are categorical, then those models are called classifiers. At the same at the same time, if the target variable contains continuous values, that is numerical values, then the model in regression models, the model searches for relationships among the variables. For example, we have got observations of the employees over the period for their salary. The additional features are their educational qualifications, experience, the level of role they are playing, the location of office they are working, likewise, we are given the input variables. Likewise, another one example we can consider for recursion is the price of house based on their location, the square feet area, number of bedrooms, and the quality of building. All those things can be input features. In these two examples, in first example, the salary of employee is the target features, and the second example, the price of house is the target features. So here these target features are called dependent variables, and all other input features such as education qualifications, experience, the role, the department, the location of office, all those things can be called as independent variables. Why we are calling it independent variables? In regression, we assume that the input features don't have any relationship with other input features. For example, we think that the experience doesn't have any any relationship with other input features such as the educational qualification, the location of office, or the role they are playing. We assume that the experience doesn't have any relationship with all these features. Likewise, the educational qualification has no relationship with all other features in the input set. So we assume these features are having no dependency on all other features. We call these features as independent variables. At the same time, we assume that the target variable has dependency on each and every input features. For example, we feel that the salary of employee is depends on experience, depends on educational qualification, depends on the role they are playing, depends on the location of the office. Because this target variable is assumed to have dependency on each and every input features. This is called the dependent variables. At the same time, the independent variables, they don't have any relationship among themselves. They are called independent variables. The target variable or the output variable can also be called as responses, because this is the response we get from the model. This can be called responses, and the input features are also called predictors, because these are using to predict the value of target variables. So these are called predictors. And usually our objective is to find the uh, uh, find the value of target variable as close as possible. And in regression problems, we have a target variable as a continuous numerical variable. At the same time, the input variable can be anything. That is, it can be a categorical variable like a gender, religion, the or the um, or location. Likewise, we can have a categorical variable. Or it can be a discrete variables, or it can be a continuous variables. Whatever form we can have in the input variables, but regression, the target variable should be a continuous numerical variable in the regression model. Let us talk about the linear regression. In linear regression, we assume that the relationship is relationship between target variable and input variables are in linear form. Let us assume in our example, we assume we have already assumed that the salary of employee is our target variable. Then and the remaining variables are input variables. Let us say the target variable employee of salary as y, and all other input variables can be expressed as a series of x variables like x suffix 1, x suffix 2, and up to x suffix r, where r is the number of predictors, number of input variables. Then the linear regression uses the following formula to find out the relationship between the target variable and the input features. The formula is y equal to beta suffix 0 plus beta suffix 1 into x suffix 1 plus beta suffix 2 into x suffix 2 up to beta suffix r x suffix r plus epsilon, where beta suffix 0 is the an intercept that we will discuss it later, and the epsilon is a um, random errors that also we will discuss later. Now we can concentrate on the beta suffix 1, beta suffix 2, beta suffix 3 up to beta suffix r. What are these variables? These are all called regression coefficients. For example, for x1 input variable, the regression coefficient is beta suffix 1, and for x2, the regression coefficient is beta suffix 2. In our example, let us assume x1 is the experience, and y is, we already know that is salary, the employee salary. Now, beta 1 is the regression coefficient of x1, means beta 1 is the regression coefficient for experience. And our regression model has found out, as we assume that, and the beta suffix 1 value is 1.2. What does it mean? This means that if we consider two employees, the two employees have the same character, the same value for all the input characteristics except the experience. That is, the qualification, role, location of office, department, everything is same except the experience. Let us assume the employee A has experience 6 years, 5 years, and the employee B has experience at 6 years. Then the regression model says that the difference between these two employees is 1.2 times. That is, the salary of B employee is 1.2 times the salary of the A employee. So this is an assumption we can make it from the linear regression. Likewise, we can also apply beta suffix 2, beta suffix 3 to their corresponding input features. And now we can say that beta suffix 0. What does it mean? It is the intercept of the linear regression. Intercept means we assume that when the values of all the input features is 0, then the value of target feature y is equal to beta suffix 0. That is called intercept. And now we can actually, the objective of our linear regression should be the predicted values should be as close as possible to the actual values. That is for our goal of the linear regression. Then we have to identify the performance measurements. We have already discussed that when the data set is given to us for any supervised model, we split the data into training and testing. Training data is used to make the model learn from the data, and testing data is used to predict to measure the performance of the model. So now we are going to measure the measurements, performance measurements. Here, the epsilon, that is the error we have already discussed. The error is nothing but residuals. For example, the first observation, the actual value is 5 lakhs, but the predicted value is 6 lakhs. Then what is the difference between these two? That is 1 lakh, that is the residual we are calling. Let us assume the second observation, the actual value is 12 lakhs, the predicted value is 9 lakhs, then the residual is minus 3 lakhs because the predicted value is less than the actual value. Now, when we are determining the measurement of the performance, we are not considering about the sign, that is whether the value, the residual value is positive or negative. We are only concentrating on the magnitude. We are not interested in direction, whether it is in positive or negative. To overcome this positive or negative, we square the value. Now the sign value can be eliminated. So now every value of residual square has positive values. Then one of the measurements is called SSR, that is sum of squared residuals. So once the residuals are squared for every observations, the these squared residuals of every observation can be summed up to find out the SSR. SSR is nothing but sum of squared residuals. And the aim of our linear regression should be to minimize this SSR value. Another one measurement used to predict the performance of a model is R square. The R square is a coefficient of determination, tells you that which amount of variation in Y can be explained by the dependencies on X. That is how the variation can be explained by Y. That is what founded by in R square. Actually, the large R square is the better value for our regression model. If the R square is higher, the model is better. Then the R square value is in the range of 0 to 1. Having higher R square is our aim of the linear regression. If the value of R square equal to 1, the corresponds SSR equal to 0. So our goal of regression model should be to have a higher R square value by minimizing the SSR values. And this is a graphical representation of linear regression, and the line represents the linear regression. It is a simple linear regression because we are considering only one input variables. For simplicity, we are considering only one input variable. If it has more than one input variables, then it is called a multilinear regression. In this graph, we can understand that the green circles are actual values and the red squares are the predicted values. The dotted gray lines represents the residuals, that is how far the predicted value is from actual value. And the line means the y-axis at beta suffix 0. That is the intercept. We have already discussed that. So linear regression with an example. In the example, we are going to have a data set called e-commerce customers. That is a shop. It is selling its products through e-commerce. They have got their own website as well as an app, and they have observed and then the customers' behavior or customers' data over the period. Using that period, they just want to uh, determine how the yearly spend would be for any customers who have got different kind of characteristics. I am going to use the Jupyter notebook, and for the convenience, instead of typing everything, I have the complete code in a notepad. The notepad contains the complete code. One the advantage is the code has already been executed and there is no syntax error, and we don't have to spend time in typing and correcting the syntax. So our time can be um, very much useful in learning how the linear regression can be executed instead of typing or correcting the syntax. So this is the way we can utilize our both of our time in a great way. And whenever it is required, I will explain what the code will be doing. And in real time also, if your code does well, then you are going to work with different parameters or different data frame. Then you can just have to change the data frame name in the code. So that's the way we can be so productive. So that is the way we are also following here. First, we are going to upload, we are going to import all the packages, Python packages that is needed for this analysis. So I am entering the shift plus enter, and it is loading all these Python packages. Now you know very well that NumPy and the pandas are used for the analysis of data, and Matplotlib, Seaborn are used for visualizations, and the scale learn is used for and getting the linear regression and other predictive models also. Now we are only concentrating on the linear regression, and the train test split. These are all useful for splitting the data into training data and the testing data that we will see later in this execution. Now we are going to load the data. Here the customers is the data frame I am assigning to this data, and this is the path where I have got the e-commerce customers data set provided by that e-commerce shop. And once the data is loaded into Python, and the data frame is assigned with the name customer. So we enter the customer's database. Then the next step is we need to understand what is this data set for about. What kind of information the data set holds. So in this case, we can use the info function. Info function gives the details about how many observations in the data frame, as well as how many columns and their names, is there any null value. All those things we can get through this information, where customers is the data frame name and the info function is used. When we give this one, we understand that there are 500 observations, and 8 columns, total 8 columns. Here we have column name as email, address, avatar, average session length, time on app, time on website, length of membership, yearly amount spent. Here the first three variables are object types, and the remaining 5 variables are float 65, that is numerical variables, continuous variables. And we know that the email, address, avatar, these kind of variables are used to identify, or these are all used for communication to the customers. These kind of variables are not useful in analysis. You know that because if you change if any change in these variables, that won't impact the target variable that we are going to have as a yearly amount spent. So these have no impact on this yearly amount spent. We know very well. If sometimes we have the location or any other longitude or latitude, then that can be used for our analysis. But here it is only an address, so we are not going to use this one. The remaining 5 numerical variables we are going to concentrate. Among 5 numerical characteristics, the yearly amount spent is the one that we are going for, or that we are going to use for target variable. So what we can have some sample data to understand clearly what kind of data stored in this data frame, for which we can use the head function. The head function brings the top 5 rows. So here we know email, address, avatar, the average session length, time on app, time on website, length of membership, yearly amount spent. All these details are available here. And this is for the first customer, this is for the second customer, likewise. The average session length 34.49 for the first customer. It may be in seconds, and the time on app may be in minutes. The time on website is also maybe in minutes or hour. So one thing we need to understand is across the columns the unit may be different, but in a column the unit should be same. For example, the first customer has average session length as 34.49 something seconds, and the second one is 31.92 seconds something. Here, the all the values should be in seconds in a column. I mean, in seconds or in minutes, whatever it is, the unit should be same. At the same time, here also time and up is also all the variables should be in same. In the unit may be same. It may be hour or minute or whatever it is. It is same across all the observations. But across columns, it can be different. That is what I want to mention clearly. So here it may be seconds, it may be minutes, or it may be days, or whatever it is. And the length of membership is in years, let us assume. So what is length of membership? Every customer, the customers might have registered with the website or app. So how long they have been a membership for this shop? That denotes the length of the membership. And the last one is the yearly amount spent. It may be an average yearly amount spent by every customer in dollars. So our target variable is yearly amount spent. That is what we are going to predict. What is the next step? We need to identify how this yearly amount spent is related with the remaining four numerical variables, for which we can have a scatter plot. It gives some kind of scatter plotting by which we can understand what kind of relationship this yearly spent, the yearly amount spent feature contains with all other input features. Let us use this pair plot customers to find out the relationship in graphical form, I mean scattered plots. So when we use this one, we find out that it would take some time. And when we use this one, it took some time. Yeah, we have got the graph from which these are all called in um, the relationship among the input variables. Now we don't have to consider it and these graphs. We are very much interested in the yearly amount spent and the relationship with the yearly amount spent with the all other input variables. Here, this is for length of membership and the yearly amount spent. This graph shows a somewhat linear relationship between these two variables. It shows that we can understand that these two have a linear relationship because it is a linear relationship. I mean positive linear relationship. That means when the length of membership is increasing as well, then the yearly amount spent is also increasing. So we can kind of find a somewhat linear relationship between these two variables. The next one we can have is this is not that much a linear relationship, but here the time on app has a somewhat linear relationship. That is in the it may be in 45 or 50 degree. So it can be a somewhat linear relationship. Then the remaining two, the average session length may have a meaningful relationship with the yearly spent. This is what we have got from uh, this scatter plot. To have a clear idea, we can use a heat map with the correlation coefficient so that we can be sure about the relationship between this target variable with the input features. Okay, then we can use this one. It will create a heat map with the correlation coefficient. So when we use this code, it shows this is the heat map with the correlation coefficient. The weekly amount spent. Actually, as we clearly explained, the yearly, we know that in the correlation relationship with the same variable is 1 with itself. So the next is the 0.81. That is the yearly amount spent, the correlation between the yearly amount spent and the length of membership. So as we thought, it is a really a good correlation coefficient, so we can consider for our analysis. When we see the next one is, it is the time on app. It has got a zero point 0.5 correlation coefficient with yearly amount spent. So we can use that also for our analysis in the linear regression creation. And the next one is the average session length. It is 0.36. So it is also a meaningful relationship. First, we can consider these two. Then we can use the third one also, this average session length, by which we can identify whether our linear regression is improved or not based on the performance of linear regression models. Okay. Next, what we will do is we are going to have only these two variables. Those are having a high correlation relationship with the yearly amount spent. That is time on app and length of membership. Length of membership and time on app. Only we are going to have these two variables of the customers, and that can be assigned to a new data frame called X. And in the Y data frame contains only the target variable. This is the way we can create a two data frames. One is X and another one is Y. Y contains the target variable and X contains the predictor variables. X and Y are created, and because of using this from model selection import train test split, when we use this code, it will automatically create a training data set as well as a testing data set. And we are saying that 0.3 as a test size. That means 30 percentage of the data frame will be assigned to the testing and 70 percentage of the data set will be assigned to training. We know that the training is used to train the model, and the testing is tested data set can be used to predict to determine the performance of the model. So we are going to split train and testing the train and the test data set using this code, and the 30 percentage of the data set would be in training in testing, and 70 percentage would be in the training. So now we have split. Now we are going to create a regression model. The LM has been created, a regression model. Now this regression model is fit into the S train. S train contains the predictors variables and Y train contains the target variable. Using these two, we are going to create a linear regression model. Okay, so it has been created. Now we can find out the coefficients, regression coefficients and intercept, which we have already discussed by learning the and linear regression. So we can find out for this what is the regression coefficient and the intercept. The regression coefficient for time on web is the time on app is 37.24 something, and the length of membership is 62.76419 something. So what does it mean? If a year of membership has been increased, then the money spent, I mean the yearly spent money would be increased by $62. And this is for time on app. If a minute has been increased, then the amount spent would be increased by $37. That is what we are saying. And this is intercept. We know that when all the x values are 0, that is time and app is equal to 0 and the length of membership is equal to 0, then the money spent on would be minus $172. Sometimes it may be a meaningful or meaningless. We can consider it or not. That we can do recursively and to find out this one. If the performance, the model performance is good, then we can keep it as the intercept. The next one is we have to predict the value with the testing data. We know that training data is used to developing the model, and the testing data is used to evaluate the model. So we are predict the results using the tested data. Now the result data frame contains the predicted value. For example, when you see this one result, it contains a predicted value for the tested data. These are the predicted values. Now we need to create a scatter plot between the actual value and the predicted value, whether how it is, whether it is a linearly represented or it is not that much linearly, and that we can find out with the scatter plot. So this shows a really a good linear regression, linear relationship between the input variables and the target variable. So we assume that the model is good, becoming good. To get clear idea, we can have the R squared value and the variance and the mean squared error also. So when we enter this one, we have got R2 square as 0.88815009 something, and the variance is the square of errors. That is, variance is it denotes how variance between the actual values and the predicted values. It is also 0.8 is explained by this linear regression. It is also 0.8895, and the mean square error, and then that is a mean square error. The error should be as minimum as possible. It shows that 711.93, that is the mean square error of this linear regression. And we have already discussed that. One more input variable has a meaningful relationship with the yearly amount spent. That is, the average session length has a really a meaningful relationship with the yearly amount spent. So now we can include that variables also in the input set to find out whether the linear regression model has been in and the performance has been increased or not to find out. So what we will do is we will create we will create a new X data frame. Now the X data frame contains not only these two variables but one additional variable that is called the average session length. So we are taking average session length also into consideration for the development of linear regression. So now X has been created, and as usual we are going to split the data into training and testing data sets, and with we are going to fit linear regression with the new x data and x train and y train. Now we can find out what is the coefficient this time. What is the coefficient? Regression coefficient. So the coefficient has been increased from 37.24 to 38.74, and it is really nearly equal 61 point something. So the regression coefficient for time and app has been increased. Length of membership is same or equal, and the average session length, it has a regression coefficient of 25, and the intercept has a value of minus 1034 point something. Now we need to fit this linear regression with, we are going to predict a value for the tested data. So tested data has been predicted the values. Now we are going to develop a scatter plot between the actual values and predicted values to find out how the relationship is created between the actual values and predicted values in the linear regression model. So it creates. So this is the regression model we have got with these data sets. So it shows clearly a linear relationship between the actual values and the predicted values. When we compare this scatter plot with the previous one, there is really a great improvement. So we might think that we are getting a high R squared value than the one that we have got in the previous one, that is 0.88. We can have a high because the linear relationship is very good in this model. So we might expect a good R squared value. So when we can get the R squared value for this linear regression, yeah, it shows that the R square value is 0.9813, which is a really a great improvement from 0.88, that is 0.1 increased. So the linear regression shows between the actual values and predicted values are very good, and it is clearly explained by the model, and the variation of the target variable depending on input variable is clearly explained, that is denoted by the R square square. Now the mean square error is 118.68. Previously it was 711, so it is tremendously reduced. So now we can be sure that this when we include the average session time and the average session length along with the time on app and the length of a membership in the input features, the model has been improved very highly. So this is the way we are implementing the linear regression, and we need to interpret the result, and we have to measure the performance of the linear model what we have developed. These are the way. This is the way we have to include in the linear regressions. There are a number of other advanced models. If the linear regression model is not working with this data set, then we can go for other those models that is having some kind of advantages. So this is the way we are developing the predictive models using the data science. And here we are using the Python code. Thank you, everyone.